All right, welcome to my second kitchen video. I'm here with Sil, Tyrion, and Stewie, and the three of us, or four of us, are going to review some predicting products. So, the video that you watched a couple days ago taught you about the 5 different types of reactions. And hopefully, from that video, you were able to see some basic structures that appear with all 5 of these types of reactions. And what I mean by basic structure, I mean A plus B makes AB. That's a synthesis reaction, and so on and so forth. So you can use those basic structures to come up with products for a chemical reaction if I'm given reactants. I've got 3 examples up here, and these are at the bottom of that really long worksheet that I gave you that I don't recommend you do the whole thing. Just do a few so you get some practice. So I'm going to do these 3 with you, and if you have any questions, obviously you can message me. So what I've got for this first one is I want to predict what's going to be made when lithium metal reacts with liquid bromine. So I need my periodic table out for this, and I find that lithium has a symbol of Li, and bromine has a symbol of Br. I remember what Miss J taught me in chemistry class when we were in school. Have no fear of ice cold root beer, bromine. Therefore, bromine is going to be a diatomic. So I got lithium, which is an element, bromine, which is an element, even though it's a diatomic. So I've got this structure, A plus B. And hopefully from your notes that you took on the last video I gave you, A plus B is going to make a product that looks like AB. So you're going to be tempted to do this, but you can't do that. And the reason for that is I have to think all the way back to October and about different oxidation states of these elements. And I remember that lithium has a +1 charge, bromine has a -1 charge. So the lithium and the bromine are going to come together in a 1-to-1 ratio. So lithium plus bromine is going to make a lithium bromide. So there's one last step here for this particular reaction, and that's to balance. And you are all very good at balancing. We know that already. 1 lithium, 2 bromines, 1 bromine, so I throw 2 out front. So if I was to say this in English, 1 mole of lithium will react with 1 mole of bromine liquid to make 2 moles of lithium bromide. And that's how to predict a product for a synthesis reaction. Let's do the next one here. Next one, I've got sodium metal reacts with hydrochloric acid, and I gave you the formula for hydrochloric acid, it's HCl. So, looking at my periodic table, sodium metal is just Na, reacts with HCl, and now I've got an element, which will be symbol A, plus a compound, which is Bx. The cation goes with B and the anion goes with X. So I've got this basic structure of A plus Bx. Hopefully you'll see that that's a single replacement reaction. And in a single replacement reaction, just like we did in the halogens lab way back in October, A and B are going to switch places with each other. So you'll end up having B by itself plus AX. So what that turns into is Na with the Cl plus hydrogen, and again, hydrogen is a diatomic, have no fear of ice cold root beer, H2. And then the last step here is to balance. So I throw a 2 out in front of the hydrochloric acid and a 2 in front of the NaCl and a 2 in front of the Na. So what I can say now is 2 moles of sodium metal reacts with 2 moles of hydrochloric acid to make 2 moles of salt, and that'd probably be salt water, plus 1 mole of hydrogen gas. And that's a single replacement reaction. The last one I've got down here says solution of tin 2 nitrate plus potassium hydroxides are combined. So it's going to be a little bit more complicated. You're going to have to dig out your polyatomic table that I gave you October, I think. And we're going to make sure we remember how to make these compounds. So I'm going to pause this really for a second because I want a different color pen. Okay, I got my black pen. Hopefully that'll show up better. All right, I'm going to make the formula for tin 2 nitrate. So I've got, and then my black pen doesn't work. How funny. So I've got tin, which has a symbol of SN, and the Roman numeral tells me it has a +2 charge. Nitrate, ATE, tells me that I've got a polyatomic. I look at my polyatomic table, pretend I'm looking at it, and I find that nitrate is an NO3 with a -1 charge. Flip the charges, make them subscripts, SN, NO3, 2. I'm going to erase those charges here just so I don't get myself confused. Plus potassium hydroxide. Potassium is K. Hydroxide is going to be OH. It's one of the very few polyatomics that does not end in 8 or 8. And I'm going to remind myself potassium has a +1, hydroxide has a -1, and so those charges balance each other out. So that's the correct formula. All right, so now I'm going to look at my 2 reactants here, and I'm going to realize that I've got 2 compounds. And it's going to take on the structure AX plus BY. I'm going to recognize that that's a double replacement reaction, and it's going to go to AY plus BX. So the tin is going to go with the OH, and the potassium is going to go with the NO3. And I'm going to see here that the tin still has that +2 charge. Hydroxide has the -1. So I need 2 hydroxides to balance out 1 tin. Don't need those charges anymore. And I've got a +1 for the potassium, a -1 for the nitrate. So those are nicely balance each other out. All right, so my last step here is to balance. And to balance this out, I'm going to see that there's 1 tin on the left, 1 tin on the right, balanced. 2 nitrates on the left, 1 nitrate on the right, so I got to throw a 2 out front here. 2 potassiums on the right, 1 potassium on the left, got to throw a 2 out front there. But that automatically fixed my hydroxides because I have 2 hydroxides here and 2 hydroxides here. So when I mix the tin nitrate and potassium hydroxide, I have 1 mole of tin nitrate plus 2 moles of potassium hydroxide will make 1 mole of tin hydroxide and 2 moles of potassium nitrate. So those are 3 examples from the worksheet that I have attached to Schoology. If you have questions, what I'm going to do after spring break is I am going to set up our first official Zoom. And that first official Zoom will just be a free-for-all, asking questions about how you're doing in isolation, to maybe from your tests that you took about stoichiometry years ago now, it feels like, types of reactions, predicting products, and it's not mandatory, it's optional, but I hope to see you there. Thank you for watching.